We are going to discuss the shear force and the bending moment diagram of a simply supported beam at the two ends, which is carrying a moment m0, which is not acting at the midspan. So beam is simply supported at the two ends, and at the distance of a from the left hand side this moment is acting. At distance b from the right hand side, the total length a plus b is equal to l. So now in the figure I have shown these two reactions acting in the same side, but they will be in opposite side, obviously, because as you can see that moment is acting like this. So it is trying to rotate the beam in this direction, means it is trying to press this end in this downward direction and lift this end in the upward direction. So as a result, the reaction here will be to stop this end from rotating. It will be in the downward direction so that this does not move up, and at this end it will be in the upward direction so this does not move down. And we will calculate these first of all. Let us calculate the reactions. So this end is A, B. So reaction here is R1, here it is R2. So net upward force equal to net downward force. There is no force in downward direction, only a moment. Taking a moment about I can write and A equal to 0. You can take moment about any point A, B, or let this point be C. So we get, taking the moment about A, moment of R1 is 0, that of R2 is in anti-clockwise direction, so R2 into L, and that of M0 is in clockwise direction, minus M0. Sign convention we have selected as per our convenience, taking this clockwise as negative, anti-clockwise positive. You can take any other convention also, like opposite convention also. So R2 is M0 by L. So this is acting in upward direction. I have taken this and we get the positive value, means this is correct. Whereas R1 is minus R2, that is minus M0 by L. So that means it is acting in the downward direction. Let me change this here. So minus M0 by L. This is R1. This is the first step. Now what to do? We have to draw the shear force diagram. Here the moment is acting. So let us take a section as usual here at a distance x from this end. So shear force Fx at this section is load on this side, left side, and load is in downward direction, so as per our convenience this will be negative. So minus R1. So this is minus M0 by L. Now this does not mean that minus R1 will be minus minus plus, so it is negative because the load is in downward direction. Now I have shown this in downward direction, so minus sign should be omitted here, because direction is shown in downward direction. If I show it in upward direction, write a minus sign, then it will be correct. So this is negative. Now for the entire beam there is no load. If I consider this point, then just towards this there is only one load and moment. So for shear force we have to consider only the load and not the moment. So shear force is constant for the entire section, remains negative, and this is minus M0 divided by L. This is the shear force diagram. Now draw the bending moment diagram. At this section the bending moment is given by, and this is for x between 0 to A. The bending moment of this load obviously will be negative. This is M0 by L into x. This is the bending moment about the section of this load, and obviously this is negative. Negative shear force, negative bending moment. So at x equal to 0, mx is 0. At x equal to A, mx is minus M0 A by L. And this is the equation of a straight line, y equal to mx. in the downward direction. So up to this point, straight line, here it is minus m naught a by L. Now for the remaining period, for the remaining span, you can start from this side also, or you can write from this side. Now mx equal to, and this is for a to L, x between a to L. Bending moment, now this section is here, distance x from this end, so moment of this about this, so minus m naught by L into x, and on this side we have another moment acting in opposite direction to this, is about this having moment in this direction anti-clockwise, where this is having clockwise moment, so this will be taken as opposite sign, so plus m naught. Now at x equal to a, now this starts from x equal to a, so at x equal to a it is m naught minus m naught a by L. So I will get this as putting L equal to a plus b, m naught b divided by L. So here the bending moment is positive, whereas at this point for the previous section it was negative. Why it so happens? This is because a moment is acting at this point, and the change in magnitude of bending moment is equal to the moment acting here. As you must have seen, in case of the load acting, point load acting at any point, the change in shear force was equal to magnitude of the point load. So here at this point it is positive bending moment, and at x equal to L you can see bending moment for this section is equal to 0. Put x equal to L in this, it will be 0. So again a straight line, and here this moment is m naught b divided by L. So you can see the change here, the change in bending moment at x equal to a is equal to m naught b by L minus m naught a by L equal to m naught, which is equal to the moment acting here. So this is how you can draw the shear force and bending moment diagram of a beam which is carrying a moment which is not acting at the mid span of this. Now suppose the beam is having the moment which is acting at its mid span, m naught. So in that case a, b each will be equal to L by 2, and so you will find the reactions here. This m naught by L, in that case what will be the reaction? It will be same, m naught by L. So what will be the change in the bending moment and the shear force? This you can easily see. So here you will take R1 plus R2 equal to 0, same, R1 equal to minus R2, taking moment about this end, sigma of MA equal to 0. So this gives, this is R1, this is R2. So about this end, this is end A, this is end B. I am taking the moment, so R2 into L is equal to m naught. So R2 is m naught by L and R1 is m naught by L with the negative sign. So I have taken this in the downward direction. Now if you draw the shear force diagram, it will be same, negative equal to minus m naught by L, and if you draw the bending moment diagram, in that case for this section the shear force or the bending moment is given by mx for 0 to L by 2. R1 into X, it will be negative, minus m naught by L into X. So at X equal to 0, it is 0, and at X equal to L by 2, this is equal to minus m naught by 2. So this is the diagram. Minus m naught by 2 plus m naught by 2. This will be the change. Now after this, let us discuss another case in the next discussion. So next we have a simply supported beam supported at the two ends, and it is carrying the moments m1 and m2 at the two ends. Suppose these are the reactions R1 and R2. This we have to find first. So again we can write that R1 plus R2 is equal to 0, as there is no downward load, and taking moments about this end and A and B. Sigma of MA equal to 0, so this means moment about this. Moment of reaction R2, anti-clockwise direction, let us take this as positive. So R2 into L, moment of M2 in same direction, minus M1, that is having opposite moment in this direction, is 0. So this gives R2 is M1 minus M2 by L. Let us take M1 greater than M2. So this is positive. So this means this is acting in upward direction. Whereas R1 is minus R2. So R1 is acting in the downward direction. So I can show it acting in the downward direction. Now again take this section here at a distance x from this end. So let us draw the shear force diagram first. Fx is equal to the moment of this force in downward direction, so it is negative. The force only, not moment, minus R1. So the shear force here you can write down. The value of R1 is given. So the shear force diagram, it is very easy to draw. So R1 is minus M1 minus M2 divided by L. So you can write the value of shear force, M1 minus M2 by L, and this is minus. So now let us write the value of, let us draw the diagram for the bending moment. Mx is equal to moment of R1 about this section and plus or minus the moment M1. There is no other moment or force acting towards the left. We have only one moment and one force. So Mx is R1 into X with negative sign. Moment is negative and M1 is having a positive moment, plus M1. So at X equal to 0, Mx is M1. The moment is positive because we have a positive moment acting here. So this is M1 at this end. And at X equal to L, Mx is M1 minus R1 into L. So you have to calculate this M1 minus R2 into L, and you will get the moment at the other end, bending moment at the other end, is equal to the moment which is acting at the end B, that is equal to MB. So I can write the value here of R1 and calculate. So this is equal to M2. Now bear one thing in your mind, that I have written here the negative sign and shown here it in downward direction. This is our negative direction, this is positive direction. So it does not mean that you always multiply that with the negative sign. If I show it like this, then you have to multiply this with a negative sign. Here you have to write only the magnitude, M1 minus R1, that is magnitude of this into L. So this is equal to M2. So here we have M2 and join them with a straight line. This is the bending moment diagram of the beam. So this is how you can easily draw the shear force and bending moment diagram. We can also draw the shear force and bending moment diagram of a beam in such case which is carrying a uniformly distributed load. So let us discuss this case also. So here you can see this is the next case. The beam UDL W per unit length, two moments at the two ends, simply supported at the two ends, and you have to find the reactions first. So this is end A, this is end B. You can take the moments about the end A equal to 0 for equilibrium. So I can write total load W into L is acting at the midspan, L by 2 distance from here, L by 2 distance from here. So taking moments about this end, moment of this reaction in this direction, let us take this as positive direction, anti-clockwise. So R2 into L. M2 is also in same direction, plus M2. M1 is in opposite direction at this point, and this load is having a moment in clockwise direction W L by 2 at a distance L by 2, WL at a distance L by 2 here. So about this it is having clockwise moment, so negative. So minus WL into L by 2 is equal to 0. So we get R2 is WL by 2 plus M1 minus M2 divided by L. And R1 you can find by taking the moment at the other end, or you can also write that R1 plus R2 equal to net downward load W into L. So R1 is WL minus R2. So R1 is WL by 2 minus M1 minus M2 by L. Now draw the shear force diagram. Now you can see clearly that if the two moments would have not been present here, or the moment M1 M2, if they would have been same, in that case the shear force would have been 0 at the center, because there is a UDL. So Fx at a distance x, so taking this section, cross section at a distance x from this end, the shear force is equal to R1 is making a positive sense, so R1 minus W into this is x, so total load W x for a length x, W per unit length, and okay, these are only two loads, we don't have to consider the moment here. So this is putting the value of R1, WL by 2 minus M1 minus M2 by L minus W into x. So this gives at x equal to 0. The moment is WL by 2 minus M1 minus M2, sorry, the shear force is divided by L, which is equal to the reaction R1. So this is the equation of a straight line, y equal to mx plus c. So here the moment is equal to shear force, sorry, not moment, it is equal to R1, and at x equal to L the shear force is WL by 2 minus M1 minus M2 by L minus W into L. So minus WL by 2 plus M1 minus M2 by L, which is equal to minus of the reaction at the other end. So here the moment is negative. Sorry, shear force. I am again saying moment. It is shear force. And in between here it is 0. So you can check what is the value at x equal to L by 2, and then you can draw these diagram joining these two with a straight line. So if I take L by 2 here on this side, x equal to L by 2, you will find that the shear force is negative. So it will be crossing this in this first half. I leave it to you. Check what is the value of the shear force at x equal to 0. So you will find it a negative value. So if you put x equal to L here in this equation, so it will be obviously a negative value, means below this. So it will be x equal to L by 2, not L. So WL by 2 minus M1 minus M2 by L minus WL by 2. So it is a negative value. So it will be in this half. So this is the shear force diagram. It is 0 at some value, for some value of x from this end, not at x equal to L by 2. And this is because two different moments are acting at the two ends. Now we can draw the bending moment diagram taking the same section. So mx is moment of R1 positive, R1 into x, minus moment of this total load is Wx acting at a distance x by 2 from this end, Wx by 2 x square by 2, and M1 is also making a positive sense here. So put the value here and find the bending moment. So you will find that this diagram will be a parabola. So just put the values here. R1 is WL by 2 minus M1 minus M2 by L x minus W x square by 2 plus M1. This is a parabola. So at x equal to 0, what is mx? This term is 0, this is 0, this is M1. So here it is having a constant value equal to the moment acting here, M1. At x equal to L, what is the bending moment? Put x equal to L here. So WL by 2 into L, WL square by 2, and this WL square by 2 will be cancelled. This is L. So minus M1 plus M2 plus M1. This is equal to M2. Positive, and here this is equal to M2. And in between these, the diagram will be a parabola. And it is maximum where the shear force is 0. So at this point, here we have, this is M2, this is M1. M maximum. You can calculate what is the value of the maximum bending moment. So how will you calculate? Put shear force equal to 0, and where the shear force is 0, then you can find put fx equal to 0, then get the value of x. At that value of x, find what is mx. So that will be the maximum bending moment. So this is how you can draw this diagram of a beam which is having a UDL over its whole span. So this is all for this discussion. See you next time.